Hello guys, welcome back to my videos. Today we're doing a new tutorial. Today I'm going to be showing you how does raycasting work and what it is, and I'm going to show an example in C#. So first, what is raycasting? For example, you have a character over here, your player, and this player has a gun. For example, imagine if he shoots this direction and it hits a wall, hits a ceiling, and imagine there's a player on the other side. Now the gun should not hit the target over on the other side because there's a wall in between them. So how does the gun know, or the projectile know, if there's a wall in the way? So basically, it projects an invisible line, and it would stop whenever it detects if there's a wall in the way. So now we know what a raycast is. Let's see how it works in detail. It needs few parameters first: start position, direction, distance, and step. It requires all these 4 parameters. So let's assume the start position is 0 0, just for a test, and let's imagine let's imagine the raycast is going diagonally. So let's do 0.5 for example. So right now it's showing I'm currently writing in vector 2, so only x and y, x axis and y axis. So you can extend this to a z axis, but just for simplicity I'm gonna do in 2D. The distance tells the raycast how far it should detect the object. So maybe it detects things from 100 pixels or 100 meters away, whatever. So let's, for example, do 100 like this. Step requires a bit of information before I actually explain it. So first, how does a raycast work? So basically, imagine this is the starting point of for example, there's a gun over here. The starting point is right over here, and it fires a raycast. By default, of course, raycasts are invisible. So it fires a invisible line until it hits something. So how does it check if it hits something? So basically, every step amount of units away from the starting position, it would check if there is something, if it overlaps with anything. So for example, here is a cube or a wall, whatever, and it fires here. For example, let's make the step size of 1, for example, and let's assume that 1 is this big. So we move this direction. We check is this point within the cube. If it's not, continue. If this is not within the cube, continue. And until it actually overlaps the cube, and then it would tell the player if it hits or not. If it hits, you could do whatever you want, like, I don't know, damage the wall or hurt the whatever the enemy is. So basically that's how it is. So step size is just how far it jumps, and to check if it overlaps anything. So I'm gonna be using this sprite text framework I made a while back. This is so that I could just show an example of how it works in code. You can use this, you can actually implement the same logic within any language or any framework or any game engine, basically. It's just how an example right now. So I'm gonna be using sprite text framework, and in the release I'm gonna be using version 1.0.2. So when you first start, there's a sample level here. It has these 3 things in. It's similar to Unity. You can actually translate it to Unity easily. Like here is start, update, and this one's unique just for graphics stuff. First, before we actually start, let me set up the test area. So first we go here. I'm gonna go initial game Windows config. I'm gonna just turn one thing on. So here is show debug hitbox. I'm gonna turn this to true and save. Then over here, I'm gonna in the level start. Basically, it would create a cube, an object that has a collider. Basically, that's all it does. When I press play right now, it would show the object with a collider here. Let's delete this draw hello world text over here, and then let's create a boolean here if the raycast has hit or not. Has hit. For now I'm just gonna leave it as false. And here basically this text will show will tell you whether the raycast has hit any objects with colliders. So now let's implement the raycast. So I'm gonna create a new function over here I'm gonna call it, make it as type boolean bool. I'm gonna call it raycast. The raycast requires only 4 parameters. These 2 are just so that I could access some stuff. You don't need this if you're not using the Spritex framework that I'm using right now. So let's start by first testing out whether the distance is less or equal to 0, or if the step size is less or equal to 0. So if either of these are 0 or below, I'm gonna return false like that here. The reason why I'm doing this, because if you, for example, give a negative distance, it would like not work, because it will cause an infinite loop. Same with setting the step size to 0 or less. Then we create a new variable over here. We call it direction dernorm here. Dernorm. Basically, it normalizes the direction. So basically, normalization means that it reduces the vector so that the length of it is equal to 1. So for example, you just in Unity you can just do the direction normalized, but here I'm doing this similar, but it's over here is just a function. So whatever you're using, just find a way to normalize it. Now we check if the dir norm is 0 or not. This, let me type it out. So basically, if the direction normal is equal to x and y 0, both are 0, return false again, because if the direction normal is 0 0, it will cause also an infinite loop. So let's prevent that by doing this. Then we create 2 variables. I've been saying infinite loop. Why infinite loop? Because right now we're gonna be using a while loop, and this part section prevents infinite loops. So now this current position and current direction is for to be used within the while loop. So let's start by typing the while loop over here. This generates it for us real quick. Wait, I forgot a new variable over here, has hit. By default I'm gonna set it to false. You have to do that. So now we have these a while loop, current distance is less or equal to distance. So basically in the while loop we're gonna be moving the point onto the next step until we hit something. This is what we're gonna be doing. So let's actually start by visualizing it. So we did I copy pasted this. This will visualize the ray points. So if it has hit something, it will be green, and if it did not, it will be red. So right now it will not do anything. It's just gonna draw a straight line. This will draw a pixel, and when I play, of course I forgot to put a return value here. For example, let's try anything here, return true. So I'm gonna put this raycast here. So this will be the position, this will be the direction, distance, and step. This will you can ignore it if you're not using the Spritex framework. So right now if I play here, of course I forgot to make it stop, because infinite loop. This will cause infinite loop right now, because the current distance will stay at 0 all the time. So to help to actually make it not be an infinite loop, we need to type in a bit of more logic. So now we're gonna be doing this current position plus equals dir norm we made earlier, multiplied by the step. So direction normalized, we're gonna give you the direction, normalized direction, and to multiply by the step. For example, if I want the step of 0.5, it's gonna be half of the amount here, and then it would add on to the current position. The current position by default is gonna be 0 here. On the next line, basically it will calculate the distance between 0 and the position. So right now I'm doing 0 to position. Basically it will do the distance from the starting point to what the current position is. So when if I test now, it should not actually like be in an infinite loop. Like, see now it shows, ignore this part, this is incorrect. Now this statement is false, but now it visualizes the raycast. It's not hitting anything. We just made it return true. So right before the visualization part section, this section will be the implementation of the logic of if you hit something or not. So right now, since I'm gonna be using this from Spritex framework, I'm gonna do the main window here, because I need to get access to all the colliders within the level, so I need this main window. So we are going to be looping through all game objects, and this section will loop through each collider within each game object basically. Now this section section is important. We do a collision test between the collider and the point. So right now you see this current position variable, it starts at 0. By default it's just 0 and it slowly increases over time. This, if you just type in the current position directly, it will not do it properly. So you have to do start position plus current position, so it would show the actual position. It would use the start position we give it before. So now let's see over here. I'm gonna add a visualizer so that we can see where it hits. If it hits something, this will show like a rectangle, and then we do has hit equal to true. And it just typed it out manually, automatically. What manually? What am I even talking about? So here, has hit will be set to true, and of course, before we do anything, we have to return has hit or not. So by default, it's false. If it hits something, it will be true over here. Oh yeah. So that we break out of both loops, we gonna do this. So has hit, because right now there's like 2 loops. So if it hits, just break again, break out of both for each loops. So this should work actually. So here we go. This casts a line from here. If once it hits the edge of the box, it shows the visualizer to show where it hit, and then it shows the part where it overlaps with the collider basically. Raycast should be invisible, so you don't need to actually draw these, so you can comment it out, all of these 2 parts, and that's basically it. So there is still some more stuff to do, so let me mess around. Now I showed you earlier that the raycasts are made out of points, and it steps forward each time to check if it hits something or not. So let's increase the step height to 100, not step height, just step size. So now I think that's a bit much. Let me reduce it, maybe 20 here. So right now, as you can see, it starts from here, it jumps to here to check if it hits something. It jumps again, it did not hit anything. It jumps until it hits something over here, and it will turn green. Yes, and it shows here as true. So let me make sure if the entire thing actually works. So let me remove the collider. So I'm gonna comment this area out. So now, as you can see over here, it's all red. So the actual raycast is actually working, and it was showing false. So now, how do we make use of this raycast other than just normal raycast? So as you can see here, you could actually spawn particles. So now I made this entire function. You could modify it. You could, for example, here, you could, instead of drawing pixels or whatever you want visualizing, you could like spawn particles or whatever, spawn particles. For example, in Unity, I know Unity has its own raycast stuff. You could use this entire code to summon single particles. So you could like summon a line of particles instantly. So yeah, that's basically it. So if you learned anything from this video, press the like button and subscribe. And if you want more, yeah, also like and subscribe. So see you guys in the next video. Goodbye.